This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 2 of graphing cosine functions. And on this video, we're going to graph these two graphs, y equals 1/2 cosine of x and y equals -3 cosine of x. Now in part 1, we ended up with this screen where we were graphing y equals cosine of x, and we found out we had these key points. Notice if we're going from 0 to 2 pi, the values go 1, 0, -1, 0, 1. Those are our ordered pairs. And so I have a graph going here from actually 0 to more than 2 pi, but between 0 and 2 pi, that's one complete cycle of the cosine function. Starts up here at 0, 1, goes down through pi over 2, and then down here below pi at -1, and then we're coming back up and ending up here at 2 pi 1. The domain was -infinity to infinity, the range between -1 and 1. The amplitude is 1. That's always the absolute value of the coefficient of the cosine. So it's, you don't see it, but there's a 1 times the cosine. And the period is 2 pi. That's the full cycle. So I've compressed that information here and drawn, again, y equals cosine of x. You see it over here. I didn't put all those extra little marks like pi over 4 and 3 pi over 4. I just put the key points. So I have 0, 1, pi over 2, 0, pi -1, etc. Now, what if we wanted to do 1/2 cosine of x? Well, I know if I remember these key values, 1, 0, -1, 0, 1, that's what the cosine of x is for these x values. So we're just going to have to do 1/2 times each of those. So I'm going to have 1/2 times for each of these, right? I'm running out of room here. So I have 1/2 times 1, 1/2 times 0, 1/2 times -1, 1/2 times 0, and 1/2 times 1. So you would get 1/2, right? 0. This one here would be -1/2. 1/2 times 0 is also 0, and 1/2 times 1 is +1/2. So let's graph these ordered pairs over here. So you have 0, 1/2. And I did make a mistake here. I do need to write that that was at 1 and that this is -1. You want to make sure that you do mark both your x and y axis. So I've got 0, 1/2. So that's going to give me right about here. Pi over 2, 0. That's going to be in the same spot, right? We've got pi -1 half. Remember, it's 1/2 times -1, so pi -1/2 is about right here. 3 pi over 2, 0. That's right here. And 2 pi +1/2. So basically everything is just starts a little bit lower. It's because the amplitude changed. Okay, and this would just continue, right? So we go through here, etc. And so what you see in green is the graph of y equals cosine of x. Now here's something interesting. If I would have just marked, oops, 1 second. If I would have changed this 1 to a 1/2, and I look at the red graph, then that is the graph of y equals 1/2 cosine of x. In other words, you can just take the same graph you did for y cosine of x and change that y coordinate to 1/2, and then it looks exactly the same as the red one. But since I'm comparing the two together on one graph, that's what it looks like. So let's do the y equals cosine x by itself in a minute after we figure out the domain. So the domain is always for the cosine and sine, any real number, so that's in between -infinity and infinity. The range, now the range only goes between, remember that's the y values, in between -1/2 and +1/2. The amplitude, that's really half the difference from the lowest and the highest point. And there's between -1/2 and 1/2, that's one whole unit. half of that is a half. And remember the easy way to get that? You just take the absolute value of this number in front of the cosine. So that would be the absolute value of 1/2 would give you the 1/2. And the period is between 0 and 2 pi. You see here, so the period is 2 pi. So here we are. Notice that I just made this marking 1/2. You don't have to make your markings at 1, 2, 3, etc. And there we have the graph of y equals cosine of x, the domain, range, amplitude, and period. And these are my key points over here, the 0, 1/2, pi over 2, 0, pi negative 1/2, 3 pi over 2, 0, and 2 pi 1/2. So here's our next example. Let's graph y equals negative 3 cosine of x. So what we see this time is we have a negative 3 in front of the cosine. So I know I'm going to do negative 3 times whatever the cosine of x is. So we know we're going to do negative 3 times all of these. And remember what those values were? You kind of want to memorize them for the cosine. It's 1, 0, negative 1, 0, negative 1. Okay, in other words, those were the values for the cosine of x if this is my value of x. So that gives you negative 3, 0, 3, 0, and oh, wait a minute. And this last one, I did the wrong thing. That's a 1. And negative 3. There we go. The amplitude will be the absolute value of negative 3, right? So this should end up being 3, and we'll see if that works. So let's graph these ordered pairs. We have 0, negative 3. All right, so how do I want to label my graphs? How about I call this 3, and I call this negative 3. If you would prefer to make little marks, oops, there we go again. If you want to make marks for 1 and 2, that's up to you, but you don't have to. Okay? All right, so we have 0, negative 3, right? So it doesn't start up on the positive side of the y-axis. It starts down here at 0, negative 3. Then I have pi over 2, 0, pi 3, 3 pi over 2, 0, and 2 pi negative 3. And there we have one cycle, or one period. And, you know, this is how you sort of sketch things. You just kind of, I'd use a pencil if I could. Okay, now it starts repeating. So if you want, you can, you know, do more than one cycle this way. I like to see a little more than one cycle usually. There we go. So this is the a graph of y equals negative cosine of x. The domain always for cosine or sine is negative infinity to infinity because x could be any number. I didn't do a very good job of writing that. And that does it much better. All right, the range. The y values go in between negative 3 and 3. So we've got negative 3 to 3. The amplitude, well, it's really just half the height, right? So that's 3, which is what we expected to happen. And the period starts repeating itself after 2 pi. So there we have y equals negative 3 cosine of x. Now if I were going to do positive 3 cosine of x, everything would have started up here at 0, 3, right? It would start going down first. This is sort of a mirror image. So if you want to see what y equals, let's see, what color do I want to use here? I use gray. If I wanted to see what y equals 3 cosine of x, everything would start up here and go down. I'll just sort of dot it. Okay, it's kind of cool. Okay, so the dotted line is y equals positive 3 cosine of x. And in fact, the domain, the range, and the amplitude and period will all be exactly the same. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.